By the end of this video, you're going to know how to use transformations involving powers, roots, or logarithms to create a linear model that describes the relationship between two quantitative variables and use the model to make predictions. Alright, so I said some scary words in there, such as powers, roots, and logarithms. So let's go through this. Make sure you've got a calculator handy because I'm going to show you how to use your calculator for some shortcuts. Alright, so this is the same data that we used the other day, the first time we talked about the iPhones. So I want you to take your calculator and I want you to put your data into list 1 and list 2. Pause the video, come back when you're done, and I'll show you how to make a scatter plot. Alright, so now that your data is in your calculator, I always calculate the regression line before I do anything else. So we're going to go Stat, go over to Calc, choose 8. Your data is in list 1 and list 2. So I know the calculator knows I'm talking about this information now, okay? So to graph the scatter plot, and then we're going to copy it onto here. So the directions say use Statplet. You don't get to use Statplet on the AP exam, so you want to learn how to do all of this stuff in your calculator. So right up here on top, it says stat plot, right above y equals, okay? So that means we're going to go second y equals, and it's going to take us to our stat plots. Go into the first one, make sure on is selected because it won't graph anything if on is not selected, and you're going to choose the very first choice. We got a scatter plot, we got a line graph, we got a histogram, we have two kinds of box and whisker plots, and out here on the end we have a normal probability plot. So you want the scatter plot. Our data is in list 1 and list 2. So from here we can hit graph. If you don't see this like I'm seeing it, I want you to hit the zoom button and number 9, and it will zoom in so you see this data. Okay, so we're going to do a quick graph. We're not going to spend a lot of time on the graph because I know you know how to graph. So I'm going to make my x's and my y's, and so my x values there were years after. So we have 7, 8, 9, 10, 11, 12, 13, 14, 15, just to kind of give me an idea to help me keep lined up. And I'm not even going to get too into doing my y-axis right now. I'm just sketching this loose graph. So I'm following the pattern that the calculator has to show my data. So we talked about this the other day, how this was very clearly not linear. We've got a very strong curve going on here. Okay, so what can we do about that? So we can transform our data to make it more linear. So the other day we talked about, is this a linear regression model? And we said no, it wasn't. But I want you to use a residual plot to support your explanation. So we can cheat and we can make a residual plot on our calculator. So we know it's not, and we're going to support this with some more words and the residual plot. So here we have our calculator. I want you to go back into stat plot. So that's the second y equals. Go back to where you were, the original one. And so we had told it the data was in list 1 and list 2. Instead of list 2, because that's our y's, we want our y's to be our residuals, so we can actually tell it to find our residuals because we've already calculated what the line is going to be, so it knows what to do. So right above stat, you see this where it says list. So I'm going to say second stat, and here's a list of the lists, and all the way down at the bottom it said resid. That's for residual. So I want my y values to be the residual, so I'm going to hit enter. So now it's going to graph the residuals for me. So when I press graph, I'm going to hit zoom 9, see if I can get a better picture of it. There we go. This is our residual plot. So we're going to roughly sketch it. Okay. So remember, this is where our residuals are 0. So it's 7, 8, 9, 10, 12, 13, 14, 15. Now if the loose sketch is really bothering you, you can use your trace button and it will tell you when x is 7, your y value is whatever, to kind of help you. But I'm just going to kind of do a quick sketch here. it gives us an idea. And the idea is we clearly see a pattern because we have these two guys that are above, then the whole group that's all below, and then another whole group that's above. So we have a very clear curved pattern on our residual plot. So that's what we're going to say over here. We know it's not linear because the residual plot shows a pattern. All right. So that's really all review. That we already know how to do. Here is where things are going to get a little different, okay? So since we expect the data is nonlinear, we cannot make a linear regression model from this. However, we can transform the data to make it more linear. First, we need to decide what type of function we think the data would best form. So this, it starts off low and then it goes up very, very quickly. This is an exponential graph. So we're going to say exponential here. Now your general form of an exponential is y equals a times b raised to the x. It's not something I'm expecting you to have remembered, but that's the general form of an exponential function. Now, algebraically, what is the inverse of an exponential function? This is what you did in Algebra 2. The opposite of an exponential is a logarithm. So if you want to undo an exponential, you need to take a log. Okay, don't panic. Usually this stuff is just given to you. You don't have to come up with any original here. Transformation model will be given to you. So how can we transform our data using our inverse? So here's your original model. If I take a log of both sides, let's see what happens. If I say log of y equals log of ab to the x. Okay, now it's not quite in its proper form. This needs to be expanded out. When you have an exponent, it can go in front. These are these rules that you would have learned in Algebra 2. Plus log of b. And so we're taking the log of both sides of units sold. If you're in panic mode right now, just kind of go with it. Don't panic yet. All right? So let's take a look. And so we said we're going to try to inverse the exponential function by taking the log. Let's flip this over and see what happens. So here we have the same data from on the front. It should already be in your calculator. I want you to take the log of the units sold and find those numbers. So we can shortcut this, go into your stat edit. So the actual units sold are right here in your list 2. So go over to list 3 and highlight L3 and press the log button. We're going to just tell it we're going to take a log of everything in list 2. So when you do that, there's the log numbers for you too. So take a moment, pause the video, fill these numbers in. Alright, so here I have this filled out. Now we're going to sketch the scatter plot. So we're still going to have our x and y axes, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, let's have our calculator draw the scatter plot for us. So what we're interested in is our x values, and we want our logged y values. So they're in list 3. So go back into stat plot, which is second y equals. Go in, we're going to do our scatter plot, but our data is x's are in list 1 and our logged y's are in list 3. So put list 3 there, it's second 3. And then we're going to graph that. So I zoomed 9 so I can kind of see it. Now look at that. It's not perfectly straight, but it's a whole lot straighter than the original data was. So we've transformed the data to be more linear so we can actually calculate a regression line. So I'm going to just sketch this real quick onto here. Okay, much straighter. So here I feel like that's much more of a line. So we're going to calculate the least square regression line. So remember, we have our data in our calculator. So we're going to go stat, calc, and we're choosing 8. Remember, our data was in list 1 and list 3. So we want to change L2 to L3. Enter, enter, enter to get your line. So here's our 4 important numbers. Look at our correlation coefficient now. 0.98, our R squared, like how good will our line predict? Pretty high. So let's take A and B, and we're going to plug them into our regression line formula. So remember, it's y hat equals negative 1.546 plus let's go with 184x. But remember, that wasn't actually just the y's. What did we do to the y's? Is we took the log of them, so I'm just going to write log here because we did this. And in context, we took the log of units sold .546 plus 0.184, and our x's was the years since 2000. Okay. Now, do you think the regression line is a good fit? So when they start talking about, do you think the line is a good fit, that's your hint to go look at your residual plot. All right, so let's take a look at our residual plot. We're going to sketch it. So I'm going to just give myself a place here. Okay, so residual plot. You're going back into stat plot. So we have second y equals. Go back into the first one. We're still doing the scatter plot, but now we want to do the residual for our y value. So instead of L3, second stat, go down to 9. For your residuals, once you have that selected, you can graph. I always zoom 9 after I graph so I can get a good look at it. Look at that. I don't see that same curved pattern. It's much more scattered, so I'm pretty happy with that. I'm going to do just a really quick sketch of this graph so I have proof of why I think it's linear now. Okay. All right, so now my residual plot has a nice scatter to it. So I'm going to say yes. The residual plot shows no pattern. All right. Okay, so it's scary, but usually what happens is they tell you exactly what they want you to do, like take the log of the units, and then you'll go from there. Okay, so now we're going to, according to this model, we're going to make a prediction. According to this model, how many iPhones should be sold in 2015? So 2015, that's an X value. We're going to put 15 in for years since 2000. So we have the log of units sold. This is why putting it in context is really helpful, because you're remembering that word log is there. Equals negative 1.546 plus 0.184 times 15, and you get 1.214. Now, before you go 1.214, that's how many million units were sold in 2015. No, that's how many log units were sold in 2015. So I need to undo this logging so I can figure out what just the units sold were. So I don't know if you remember from Algebra 2, to undo a log, it's a log base 10, it's an understood 10. So if you raise it to the 10, that cancels out your log. So if I could raise one side to the 10, I'm gonna raise the other side also, okay? So what this does is this cancels out the word log. So now we just have the units sold equals, and we're going to take this and we're going to say 10 raised to the 1.214 is 16.37. So they're predicting 16.37 million units, okay? This is why I like putting this in context. It reminds you that we took the logs, we have to undo it. If it just was units sold to begin with, we wouldn't have to worry about changing our answer. All right, so we're going to calculate and interpret the residual for the actual number of iPhones sold in 2015. Well, 2015 shows that we had 13 million iPhones sold. So that's our actual. So you take your actual minus your predicted. Remember, this is to get your residual. And we get negative 3.37. Well, what does that mean? Okay, so let's interpret it. You can go back a few lessons ago and there's the interpretation here, but here's our little math lib. So we have the actual Y context. So our Y context here is the number of iPhones sold. Was 3.37 million. So the actual was lower than, less than predicted. For 2015. That's our X context. All right. So hopefully that wasn't too bad. It's a lot to take in all at once. Let's do some summarizing. All right, so some of our big ideas. So we have a couple different functions that we can see, and we can talk a little bit about what their plot is. So we have our function and the plot. Okay, so we could have a linear function. That's what we want. Everything we do in AP Stats needs to be about a line. And that's just X value versus the Y value, okay? Then there's something called a power function. So that's like what we would have done on the very front, and that's where you're taking the log of both sides. So the log Y versus the log of X, okay? Or we also have an exponential function, and that's what we just did, where we took the log of Y versus X. We didn't change our X, we only changed the Y value, okay? All right, now, to make predictions, like we just did with 2015. You're going to plug in your X and solve for Y, just like always. You may need to undo a log or a root. So that's only if something's been done to the Y value. So if you took the log of Y and wrote, this is what we did, because y has the log, you'd want to undo it. So you'd raise both sides to 10 to cancel the word log out of your formula. If we had just said y equals and something happens only to the x, you don't need to worry about changing, only if your y has had some sort of operation done to it, okay? Other ways to cancel, you have a natural log, will cancel e raised. Those are opposites of each other. Like y cubed can be canceled by taking a cube root, just like y squared can be canceled by taking a square root, but that's only if something's happened to y. If it just says y and you haven't done anything to y, you don't have to undo anything. You'll just plug in and solve as normal. So normally I would have you check your understanding on your own, but I think this one needs a little bit of extra help because it's a lot going on. So you are a marine biologist interested in analyzing the lengths and weights of Atlantic rockfish. You and your crew will be going out to catch rockfish to collect data. So you did all this, and here's your data you collected. Clearly, it's not linear. It's got a pretty good curve to it here. It's looking exponential. All right? So what they did, because length is one-dimensional and weight, like volume, is three-dimensional, they used a power model where they took weight equals a times the length cubed. So that, see how they're giving you the formula that they use to make the transformation. They're not making you come up with it. All right? And so here's the new scatter plot, which is much more linear. And here's our summary statistics. So you see these a lot on the AP exam. So let's kind of look at what we've got going on here. This says weight versus length cubed. Well, length is an x value. So we're saying y versus x cubed. Nothing's happened to the y. That means we're not going to have to undo like we were talking about up here because they haven't done anything to the y. It's just going to remain y. So we're good there. Now, when we look at these, there's a whole bunch of stuff. All you need to worry about right now is right here. The constant is always your y-intercept. Okay? So the constant is the y-intercept. And then right below it, it says length cubed. Well, length is the x value. This is actually your slope. So the constant is always the y-intercept, and the value right below it is always the slope. And it looks different depending on which software they use to predict, to make their summary statistics, but it's always one's labeled constant and the one right below it is slope every single time. So you don't have to worry about what the data is. They did the regression for you so you can write your equation here. But look what else they've got. They've got S, that's your standard deviation of your residuals. That's your R squared. It's 99.5%, so it's a really good predictor. They don't ever give you R because you can just take the square root of that to get your correlation coefficient, okay? And so there's other things going on over here. Don't worry about the things you don't know yet. Only worry about these things for right now. Eventually we're going to talk about p-values, but not till next semester. Okay? So if you don't know what it is right now, just concentrate on the pieces that we're talking about. Now, so give the equation of the least square regression line. Well, we have the y-intercept and we have the slope. Okay? So we have the regression line would be y hat equals, our y-intercept is 4.066, and our slope is positive, so I'm going to say plus 0.0146. I'm going to go ahead and use the whole thing, and then our x value, remember, is x cubed. Okay, so I want to put this in context. What is our y hat? Remember, y hat is your weight. And then your x X value was length, so I'm going to say length here, cubed. All right, so there it is in context. Now, pause the video, answer part B, and let's see how you do. Unpause when you're ready. All right, so our predicted weight is, here's the equation of our line. I plugged in the weight of the length of the fish we caught, and it has to be cubed because that was the power model that they applied. And I got 688.9 grams. I do not need to undo anything because I haven't done anything to the Y value. This is straight up what this is. If we had taken a log of the weight somewhere along the way, we would undo that at this point, but there's nothing that needs to be undone, so that's your actual answer. Hopefully this isn't too bad. When you come to class, we're going to do some more with this, so let me know if you have any questions, and I'll see you in class.